Hello.
Yes, sir.
Yes, sir.
We will start in 5 minutes or
Hello,
so.
sir.
Hello. I'll start 1:05. Just in 5 minutes. Both of them under the tutorials of this week. I will explain it. I will go through it in detail. You don't need to memorize anything. You don't need to remember any function. Everything is there. It's ready for you to go through it later, to have a look at it later. I am happy to answer any questions after the tutorial if you still don't understand. I am happy to repeat the calculation if you don't understand. So relax if you don't understand everything at once. That's absolutely fine. We are not scientists or experts of Excel. I don't expect you to be expert in Monte Carlo. The calculations are not that advanced. As I said, I'm happy to answer any question and repeat the calculation if you need to. Let me first share the Word document file. Can someone confirm you see my slide?
Yes, sir.
Okay. So I will explain what we will be doing today in a Word document file. As I said, everything is there. You don't need to remember anything. I will go through the calculations as well. I'm happy to answer any question, even if the time exceeds 1 hour. That's absolutely fine. So no rush. Don't worry about anything. Firstly, when we will be using our simulation, Monte Carlo, we will need to briefly understand what are the distributions. You know, like the normal distribution, uniform distribution. We usually use normal distribution for almost all our calculations, but what are they? I will just explain some of them briefly. The purpose of this explanation is not to show you all types of distributions. It's just to show you that there are different types, and different types of them may be used at different times. There are various distribution curves you can use to set up Monte Carlo simulation, and these curves may be interchanged based on the variable. Microsoft Excel doesn't have a formula called do Monte Carlo for me. There's no such thing to say do Monte Carlo for me, please. I don't want to do it. We need to do it step by step. As I said, it's not complicated, but Excel doesn't have anything like Monte Carlo function. We will need to do it step by step, and I will go through all steps. But let's first explain some distributions. We have normal uniform distribution. There is equal likelihood anywhere between the mean and max. A uniform distribution looks like a triangle. So in uniform distributions, you have minimum and maximum, and the probability for all values between them is similar. Imagine a rectangle. You have end and the beginning of the rectangle, a curve which looks like rectangle, and all the values between them have similar probability because the rectangle is straight, you know. Then we have normal distribution. What all of us have used it the most, the standard bell-shaped curve. This Monte Carlo simulation formula is characterized by being evenly distributed on each side. Median and mean are the same, no skewness. and the tails of the curves go on to infinity. So this sometimes is not the best curve. For example, if you want to estimate the curve for house prices, where few top-end houses increase the average mean above the median. You know, there's one house that is very, very expensive. You want to build a formula for house prices. One house is very, very expensive. That spoils the normal distribution. It's not normal anymore. So it may not be ideal for every case, but that is the most popular distribution. We all know it. Log normal distribution, a distribution where the logarithm is normally distributed with the mean and standard deviation. So the step is similar to the normal distribution, but it just uses a logarithm instead of just a number. We have Poisson distribution. This is likely the most underutilized distribution, so it's not popular. By default, many people use normal distribution curve when Poisson is a better fit. So even when it's a better fit, people don't use it. Poisson is best described when there's a large distribution near very beginning. You know, imagine a call center. A call center, when they open it, immediately after they open it, you know, the working hours start, they usually receive a lot of calls right at the beginning. So then after a while, they will receive, for example, very, very few calls. There are breaks. This is called Poisson distribution. Anyway, the purpose here is not to show you all types of distributions which are available in Excel. Just to show you that there are different types of distributions. This is building the model. This is our example for today. This is what we will be doing on Microsoft Excel. But let me explain it to you firstly in Word document. What is it? For this setup, we can assume distribution of 100 iterations or 1,000 iterations. The difference between Monte Carlo and manual calculations is that in Monte Carlo, we can run the simulation so many times in one click. I'll just show it to you. We can tell Monte Carlo to tell Excel to run Monte Carlo for me 4,000 times, 100 times, 200 times. It's just one enter. That's the difference between Monte Carlo and manual calculations. It's so quick for you to do the calculation. In the step one assumes a normal distribution. A normal distribution requires three variables: probability, mean, and standard deviation. So we have a value. I will explain it further on Excel sheet. We have a value. You know, we have a mean and standard deviation. You know the normal distribution. We have a mean in the middle and curve is distributed to both sides. We call it standard deviation. We will tell Excel to pick a value for us based on that mean and standard deviation. So a value randomly. Pick a value for us between the mean and standard using mean and standard deviation. We will tackle mean and standard deviation in our first step. I assume a finance forecasting problem that consists of revenue, variable and fixed expenses, where revenue minus variable expenses and fixed expenses profit. You know, in finance, if you want to calculate the profit equals revenue minus the variable cost minus fixed cost. That has nothing to do with Monte Carlo. That's in business, you know. If you want to calculate the profit for anything, the profit equals revenue minus variable cost minus fixed cost. I will explain further. And then we will have distribution curves assumed for revenue and variable cost. Why not for the fixed cost? Why there's no distribution for the fixed cost? Because it's fixed. We are already saying it's fixed, so this cost doesn't change. I will perform the calculation as well. And then the example below indicated the settings for the revenue. The formula can be copy-pasted to the other cells. For this is the formula we will use. We will tell Excel to pick a value for us using the mean and standard deviation. Then we will run 100 iterations. You can use 1,000. It really doesn't make any difference at all. Then these are some steps. All the guidelines are here. Everything is explained, but I will explain it on Excel. That will make more sense. But this file takes you through the stages step by step, which formula you will use exactly. And after we have run the simulation, we will tell Excel to tell us the probability, the likelihood of you losing money. What's the likelihood of you losing money? Here it's 4.8%. So 4.8% of times we lose money in this business. The likelihood of getting profit more than 1 million is 51%. I know it still doesn't make that much sense, but I will do the calculation on Excel. I will do the calculation myself on Excel. This Word document provides all the steps that you will go. It includes all everything step by step. I will, on the chat, Hera, I will repeat the calculation. I will do the all calculations for the all tutorial. So this was just a guide. This was just a guide. Don't worry about don't worry about so far. I haven't done any calculation yet. That was just a guide. So here in sheet 1, everything is solved. All the functions that I will use are there. You don't need to remember. Now in sheet 2. In sheet 2, we have forecast, which is mean, standard deviation. We have mean and standard. Expectation, this is forecast, expectation, the mean. But the mean also has a standard deviation for revenue and variable cost. So they may change according to this standard deviation. You know, they may deviate from the mean. So the revenue benefits from the project may not be exactly this. There is a standard deviation that may change, may not be exactly 5 million. So in this example, this is the first step. That is 5 million, the revenue benefit is, you know, the revenue of the business is 5 million. Then we have variable costs again. Then we have fixed expenses, fixed costs. Profit in all businesses, profit equals revenue minus variable cost minus fixed cost. So revenue 5 million minus 3 million minus 1 million. Of course, it's 1 million. You know, 5 minus 3 minus 1, it's 1 million. So far, what you see on this screen, all are just numbers and writing. There are no functions, nothing used. So it's just writing what you see on this screen. There are no functions used so far. So let's run the first simulation. You know, the first simulation. Let's tell Excel to pick a value for us based on this mean and this standard deviation. We will tell Excel to use normal distribution. You don't need to remember functions. I told you because they are already there. So we will use a normal distribution. We will need to use probability, mean, and standard deviation for normal distribution. Probability, we will use it using the random number, rand, then it will tell you, give me the mean. You know, random number, closing the parenthesis, then comma, it will tell you, give me the mean. Click on the mean. This is the mean. Another comma, then it will tell you, give me the standard deviation. Then click on the standard deviation. Then close it and press enter. It will randomly pick a value for you using this mean and standard deviation. So Excel will randomly pick a value for you using this mean and this standard deviation. We can copy the formula to this cell as well, but I will not copy. I just want to do it again. So we will use normal distribution. For probability, we will use random number. Pick a random number for us. Then close the parentheses. Then it will tell you, give me mean. This is the mean for variable cost. You know, we want to pick a number for variable cost. Then it will tell you, give me the standard deviation. This is the standard deviation. Then close it. Press enter. It will give you standard deviation, a random number using this mean and this standard deviation. This is fixed expense. It will remain the same. You know, it's fixed. We are saying it's fixed. So for the first iteration, it's also remaining fixed. Then we will come to profit. What's profit? Profit basically is revenue minus variable cost. Profit equals revenue minus variable expense minus fixed expense equals revenue here, revenue C6. You know the name of this cell is C6. C6 minus D6 minus D6 variable expenses minus E6 fixed expenses. Press enter. It will automatically calculate the profit for you. This is the first iteration. This is the first iteration. We use a normal distribution to pick a number for us for the revenue and variable expenses. And fixed expenses fixed. So it remains the same as before. Then we will calculate the profit. But we don't want to do it the one iteration only. Monte Carlo is about doing it multiple times. So let us do it for 100 times. You can do it for 1,000 times. It's exactly the same. So I have this number. I just drag it to 100. You can write it from 1 to 100. It's exactly the same. We want the first iteration. We want the first iteration to be equal to F6. You know, we will move F6 to here. Equal F6. Press enter. So why these numbers are changing whenever I press something? Because we have used a random number. So whenever you do something, Microsoft Excel will randomly change your calculations. Then after you have done the first iteration, select the area that you want to repeat it 100 times. By the way, all these steps are explained in the Word document, that you need to highlight area and you need to do this and that. Don't worry about it. Then you will need to go to data, what if analysis, data table. In data table, click on the column input cell, click on an empty cell, press enter and click OK. It will run the simulation for 100 times. So the simulation that we run here, it will repeat it for you 100 times.
Can you repeat, please?
Yeah, I will. It will repeat the simulation for you 100 times. So the first iteration, we want it to be this one. You know, we have already done it. We have already done it the first time. The first time we will say, just bring F6 for me. This is F6. Yeah. Then you select the area that you want the iterations to be there. You know, you want your iterations to be there. Then you go to data tab at the top, what if analysis, then data table. The steps are explained in the Word document. You click on the column input cell, click on an empty cell, press enter, press OK. It will repeat it 100 times, or whatever you want. Then, what do you want to use these numbers for? So what? There are different purposes that you can use these numbers for, you know? Here, in this tutorial, we want to calculate the possibility of losing money, likelihood of losing money. In how many times of this 100 we have lost money? You know, how many times we have lost money? How can we calculate that, the probability of losing money in this business? We will use a function called count if. Count for me if. It will tell you, give me the range. From where do you want me to count for you? I'll tell it from here. You can drag it to the bottom, or you can press the Control and Shift. It will go to the end. Then comma, count if. Look at the tab that at the top. Count if. You give the range. It will tell you, give me a criteria. The probability of losing money, it's written like this. What is the probability that the value in those cells is less than 0? Press enter. Only once in 100 times we have lost our benefit is less than 0. Only once in 100 times.
Kindly repeat it, sir.
Absolutely. Absolutely. Okay. So we have run our simulations 100 times. Then we need to use these numbers for something. So why are we using, what we are doing it anyway? What's the reason for that? Well, we want, in this tutorial, we want to calculate the likelihood of losing money and the likelihood, what's the probability of gaining more than 1 million? So the likelihood of losing money is done like this. Count if. It will tell you, give me the range. You will click here and you will give the full range to it, or you can drag to the end. Then give me the criteria. Less than 0 is written like this. You know, we have here, we have seen it in mathematics, maybe even in primary school. That's how, so the triangle looks at the 0, so 0 is better. The likelihood of losing money is 3. Why it was 1, now it's 3? Because it's random. We have used a random value, random number. So whenever we do something, we calculate something, Monte Carlo will change it automatically to some other numbers. But they will still be close to each other. They will be related. So, but what is the likelihood of gaining a profit more than 1 million? Again, write count if. Count if. It will tell you, give me the range. Click on the first cell, go to the last cell, then comma. How to write more than 1 million if the value is more than 1 million. Should be close to 50. 57. So in 57 of cases, we are gaining a profit more than 50, and it makes sense. Why it makes sense? We have revenue of 5 million and variable expenses of 3 million and fixed expenses of 1 million. So profit is likely, in many cases, around 50 to be more than 1 million. And why only around 50% of time is because we have standard deviation that the revenue may be less than this number. Doesn't make sense at all.
Excuse me, sir. I have a question.
Go ahead.
Why does that iteration 1 keeps on changing if you do like likelihood for losing money and likelihood for of profit greater than 1 million?
Why the numbers change?
Yes, sir. Iteration 1 keeps changing.
Yeah, true. It changes. You know, here in simulation 1, we have used a random number. You know, in normal distribution, you need to include probability. You know, in normal distribution curves, imagine a normal distribution curve. In the middle, we have mean. Then to both sides, we have standard deviation. So values deviate from the mean. We have told the Excel to pick a random number for us. Based on the mean and the standard deviation we have given, random number. So whenever we do something on Excel, the random number will change automatically. It will change to another random number, but still using those mean and standard deviation. So it's correct and it's good that you notice it. Whenever I press something, change something, the numbers will change. But we'll still use those means and standard deviations that we have given. Does make sense?
Yeah, I got it. So okay.
Sir, I have a question.
Go ahead.
Yeah, sir, as you said that whenever we run a calculation, so every time we have a different numbers
Correct.
on the first run we have likelihood of losing money one at one time, and now six.
Now,
Then, sir, then what's the validity and the importance of these calculations?
you know, Monte Carlo also is an estimation technique. Estimation is estimation. It's not exact 100% to say this is the value. It is still estimation. But because there are so many, it is as accurate as it gets. It's as accurate as estimations get because we have used a random number, so the values will change. That's how Monte Carlo works. But still, this value will be close to 1, 2, 3. It will be 50. The probability of using the, let me do it again, you know. Let me do it again. Let me do it again. Count if. Give me the range, what will tell you. This number and to the last one. Tell me when we are losing money. The formulas are there. You don't need to remember formulas. I don't remember them either. This time it says 6 again. So whenever we change something, we press something, you know, the values will change. You know, I just entered a random number here. It became 1. It became 0. It became 6. It became... So as you can see, the numbers change because we have used the random value. We have used the random value. We are telling Excel to pick a random number for us using that mean and standard deviation that we have given. But you know, when you have a standard deviation curve, you have mean in the middle of the curve, the peak point, and you have standard deviation to both sides. We are telling it to pick a number for us randomly, but still within this curve. So that's why it changes. Do you want me to do the whole relation again?
Yes, but before that, sir.
Go ahead.
Yes.
For the number of iterations you did 100. Is there like a fixed figure, or we can do 10, we can do 20 if you want to?
There's no fixed figure. You can do 1,000 and it's still one click. But 10 is be too few. At least 100, at least minimum.
At least 100. Okay.
Yes. You know, it doesn't make anything more difficult for you, to be very honest. You know, you just press enter. Yeah. So let me do it again. Let me do it again. Press delete. Hopefully I can delete these zeros. Sometimes if you leave something not deleted in Excel, it will cause problems for you. But anyway, okay, let me do it again. So we want to do it first ourselves. You know, we want to use normal distribution. Pick a number for us randomly using random number. Using this mean and this standard deviation. But randomly pick a number for revenue based on this mean and this standard deviation. Then we will say use the same formula. Please pick a number for us, but randomly using this mean and this standard deviation. Fixed costs don't have a standard deviation because they are fixed. You know, that's why they are called fixed cost. They are fixed. We will write 1 million again, which is the value given here. Then if you want to calculate profit, not only in this example, everywhere, profit equals revenue minus variable cost minus fixed cost. That's how it works in business. So you press enter, you will say this cell equals C6 minus D6 minus E6. Sorry, E6. Yeah. So it will calculate profit for us randomly based on the random values of revenue and variable expense. This is the first iteration. We do our first iteration ourselves. As we say, there is no function to tell Excel do Monte Carlo for me. The main difference between Monte Carlo and our calculation is it can repeat it so many times so quickly. So we said we will do 100 iterations in this case. The first one equals F6. This cell is F6, you know, based on the row and the column. It's F6. But we want to redo this 100 times. We don't want to calculate it 100 times or 1,000 times. It's not so entertaining. So we will select the area, go to data, what if analysis, data table. In data table, come to column input cell, press here, select an empty cell and press OK. Press enter, then press OK. It will run the simulation for you 100 times or whatever you want. It will run the simulation for you. Based on the different examples, different tutorials, you may want to use these numbers for something, you know. It's not just so what, these are the numbers, but so what. In this specific tutorial, we want to calculate the likelihood of losing money and the likelihood of gaining profit more than 1 million. So let us do it for the likelihood of losing the profit, losing the money. So likelihood of losing the money. Count if, count for me if. It will tell you, give me the range. Select the first number and go to the last number. I select the first one and press Ctrl and Shift to go to the last. Okay, what do you want me to do it for you? Look at the cells where the value in them is less than 0. This is the function, how you write it. You don't need to remember it. 4 times, 4% of times, there is a likelihood that we will be losing money. Well, what's the likelihood of gaining a profit more than 1 million? Well, all functions should start with equal anyway. It's Excel. Count if. It will tell you, give me the range. Press here, go to the last cell, press comma. You don't need to remember fractions. I just want to repeat because they are scary if you want to remember. I don't remember them either. When the profit is more than 1 million, press enter. 47% on times, there is a chance that to get profit higher than 1 million. See, all the chances of getting profit more than 1 million are close to 50. So they are different numbers, but they are still close to 50, you know, because it picks the numbers for us based on the mean and standard deviation that we have given. And based on that, the all values should be in that curve. Yeah, they are different, but they are still in that curve. 55, see, 48, 43, and 46. And the profit of losing money is always 0, 1, 2, 3, 5, and these numbers. All this calculation is done here in sheet 1. Everything what I did is already here. So if you click on any cell, it will tell you which function has been used. And these are the iterations and everything. Everything is there. There are 1,000 iterations here. And the function here is divided also by 1,000 to give you percent. You know, I only use it 100 iterations. Here we have used 1,000. So it's exactly the same. All the guidelines, everything is available on the Word document. Everything is, so there's Word document and there's solve it Excel sheet. I think you just need to go through it. But of course, I'm more than happy to answer any question. That's why we are here.
Hazhar, a quick one, please.
Go ahead.
So if, because when you calculated the likelihood of losing money, it gave us a value. And then when you did the second count if and calculated the likelihood of making more than 1 million, the value also changed.
True.
You guess that means the value of losing money also changed.
It's
and
true.
also we had a new value for gaining more than 1 million. So at this point, because this looks like several iterations. So
True.
at what point do you select, even if they are within range, at what point do you select to, let's say, at what point do you select these values to be able to make the informed decision you want to make?
A very good question. You know, your question is not about calculations. It's about the concept of Monte Carlo. You know, it's not about the exact number that we get, but you can tell when the value makes sense. You know, we can tell from the model if it makes sense or not. Based on the mean and the standard deviation that we have, the value should lie between them. You know, this side and this side of the mean, according to the standard deviation that we have given. But when to stop? How many iterations? Like how many things to run? You know, which value to keep? There's no answer for that. It's up to you, whichever you keep. Whenever you have done all your calculations, you can leave it there. So whenever you have done all your calculations, even if the probability of losing money is 3 or 4 or 5, it won't make difference. As long as you have gone through all the steps, that's how Monte Carlo works. You know, whenever you place something, because we have used a random value, the numbers will change. And when to stop is basically at any point when you have done all your calculations. As long as the values lie between the mean and the standard deviation to both at the side, this is fine. It's absolutely correct. It doesn't have to be exact 4 or 5 or 3. As long as they make sense according to the mean and standard deviation that we have given. I hope it makes sense.
Yeah, it all makes sense to me now. It makes sense to me. Thanks.
Here about the formula for profit. On Excel, it basically equals the cell that you have revenue on it minus variable expense minus fixed expense. So for example, A1 minus A2 minus A3, wherever those values are, it's just there. So the formula is very, very basic for the profit. Very basic. And it is written on the Excel sheet. Another question, what is the range of that random number occurring, like from 1 to 100? What is the range of that number occurring from 1 to 100? You know, forget about this example. Let's say you have a mean of 60. You have a function with the mean of 60. The standard deviation is 5. The standard deviation is 5. So you have mean of 60 and standard deviation to both sides is 5. So the value that we pick for that specific variable that has mean of 60 and standard deviation of 5, they will be 5 below 60 or 5 above 60 or 60 itself. So they will be 58, 55, 56, 63, 64, 65, but you will not get 66. That's how it works. If you have any question, please do ask. Formulas are there, but you still may have questions like anything. I'm very happy to answer.
Sir, I've got a question for the coursework.
Oh, go ahead.
In part B, so do we have to do the same thing as you showed us in the tutorial? I mean, doing the calculation for the 100 times, or can we use a macro to calculate only once the mean?
You will need to use iterations. It's Monte Carlo, you know?
Okay.
Yeah, you will need to use iterations because if I just, in this tutorial, for example, I just did one iteration, it's not Monte Carlo, it's still manual calculation, you know? If I just pick a random number using mean and the standard deviation, that's basically I am using Excel for calculating standard deviation. So you should use some iterations. Yeah.
Okay. Thank
That's
you.
why it's called Monte Carlo. Any question at all, just go ahead. I would like you to solve this tutorial. I know it might still not make that much sense if you have never used Excel for Monte Carlo, but I think it's not that complicated. If you go through it and go through the steps, I think you should be fine. You should be fine. And if you have any question,
Yeah, Hazhar, one more.
go ahead.
So let's say we are given a couple of variables. Let's say a set of 10 numbers.
Okay.
Now, if we are given this set of 10 numbers, definitely with this set of 10 numbers, we'd use it to calculate our mean and our standard deviation, right? Now, despite having calculated this mean and standard deviation, would still also have to randomly generate the mean and standard deviation, or would have to use those ones as static values and then run the simulation.
You know, when the distribution is normal, so we have normal distribution. In all normal distributions, we have mean and standard deviation. So we tell Microsoft Excel, according to the normal distribution formula that we use it, to pick a number randomly for us using mean and standard deviation. So if you have many variables, if you have 10 variables, all of them have mean and standard deviations. So for example, in this example, I had two, the revenue and variable costs. I used it for both of them. I don't know if it makes sense or not, but please ask if it doesn't.
Okay.
I will run tutorial again at 3. I'm not leaving now if you have any question, but I will run tutorial again at 3. And if you want to join, you can join again. I will, you don't have to. Your attendance is recorded for this week. That's it. You done the lecture, you done the tutorial. But I will be there again and do everything again at 3 if anyone wants to join. But I'm here still if you have any question.
Okay, another question, please.
Go ahead.
Yes, looking at the souvenir book project, that's the template for part B of the assignment. I don't know if, because I tried to open it to merge it with what you just explained, but on that I can see network, I can see parts, I can see graphs.
Yeah, good one. That one is not related to this tutorial. So it's related to the tutorial of next week, that example. So the part which is related to this tutorial, we haven't given example for it. So that is template doesn't include the part of the coursework which is related to this tutorial. It only includes part, like one part. You know, it's written part B. It's not part A. Don't worry. I mean, go through it, but it's not related. It's not similar to exactly what we did here.
Okay, so your explanation has to do with the part A of the coursework.
I mean, this is tutorial. This is not the coursework, but yeah, it makes sense. It will make you, and you should be able to understand it. But it's not the solution of the coursework. It's just tutorial. Yeah, but yes. Any other question? So if there are no other questions, that would be it for this week. You have attended the lecture and the tutorial. I will run the tutorial again at 3 if someone wants to. You don't have to. Everything that's it from my side to you. But I will be there anyway at 3 again. If someone wants to watch again, I'll do everything again. I'm happy to answer any question again.
Hello, Dr. Hazhar.
Hello.
Thank you very much. I guess the issue here for some of us is we're just having this for the first time. And I think, as we would say, practice makes perfect. I think the issue here is for us to first digest what you have just showed to us. And probably if we have questions, I believe you will not hesitate to answer if we send an email to you after practicing, because there's some people like us, we will understand more if we sit down, have a time to digest with what you have showed us, demonstrated to us, and we can come back to you with any question.
No worries at all. Absolutely fine by me. You can email, you can ask next week. I'll be with you for the lecture. It's absolutely fine. But I do understand, you know, it's your first time to see it. It's not about the difficulty of the tutorial, to be very honest with you. But maybe even if it was my first time, it will still, I will find it difficult. So yeah, I understand that you need to practice. You need to go through steps, honestly. You need to go through steps step by step, follow the Word document, then go to the Excel sheet. Excel sheet is also, there is one sheet which solve it. Go through it step by step. If something doesn't make sense, drop me an email, ask me next week. It's absolutely fine.
All right, thank you.
No worries. Anyone else? Well, so that's it. That's it for this week, unless someone wants to join later, which you don't have to. Have a good day. Have a good day, everyone.
Thank you. Have a good day.
Thank you very much.
Bye bye.
Thank you, sir.
Sir,
Bye,
thank you,
sir.
sir.